Look at 10.2. So when testing hypotheses using p-value, if the p-value is large, reject the null. That is false. When the p-value is small, then we reject the null. So this is false. So small p-value, reject the null, and favor the researcher. What we're going to do in 10.2. All right, so we're going to do hypothesis testing. And to do this, we're going to go stat, proportion stat, one sample with summary. And we're going to do x by n. So x is 90, 125. Hypothesis testing. The null is equal to 0.6. And this is a right tail test. So change this to right tail. The test statistic, the z0 is always going to be this z-stat. 2 decimals is 2.74. And then the p-value to 3 decimals is 0.003. Now here's how we check. If the p-value here is less than alpha, then we reject. So here the p-value is less than alpha, so we reject the null because the p-value is less than alpha. Greater than alpha, we do not reject. So that's going to be the measure that we use. Okay, so do another example. This time x is 66. And n is 150.5, and then less than 0.5. So compute. And let me turn this off real quick because it's hijacking my keyboard again. All right, so p-value this time, 4 decimals is 0.708. And since p-value this time we compare, so p-value is less than alpha, so we reject. So p-value less than alpha, reject the null. Some have argued throwing darts at a stock page to decide which companies to invest in could be a successful stock picking strategy. So here's our researchers. Suppose a researcher decides to test his theory and randomly chooses 250 companies to invest in. So after 1 year, 130 of the companies were considered winners. That is, they outperformed other companies in the same investment class. So again, the researchers here, to assess whether the dart picking strategy resulted in a majority of winners, the researcher tested. The null is that it's equal to a half, so it's not better, not worse, and then it's greater than half. So it is a good strategy to use when picking stocks. So p-value is 2.635, which is large. Assume alpha is this, so the p-value is greater than alpha, so we do not reject the null. Now, to explain what a p-value is, if you wanted to print off your notes over here, I've got this definition which I usually talk through with my students, but basically the p-value is the probability of obtaining a sample statistic as extreme or more extreme than the one obtained under the assumption the null hypothesis is true. So that probability would be about 26 samples out of 100. We would expect to get the proportion larger than half. And if you look at the proportion that we got, let's see, we've got 130, right? Divide by 250 is 52%. So getting that sample statistic or more 26 times out of 100 under the assumption the null hypothesis is true. So you always just assume the null is true. Percentage is a half. So proportion is a half is a half. So now we're down to B and C. And the p-value is 26 samples out of 100. So we would go with this. All right, since p-value is large, again, we do not reject the null, and there is not sufficient evidence to conclude the dart picking strategy resulted in a majority of winners, because that is what the null hypothesis has said. Running a bit slow this morning. All right, clinical trials, 18 out of 885 patients taking a prescription drug daily complained of flu-like symptoms. Suppose it is known that 1.8% of patients taking competing drugs complain of flu-like symptoms. Is there sufficient evidence to conclude more than 1.8%? So that's the researcher's hypothesis. So we're going to say the proportion is always equal to, again, null is always equal to 1.8%. And then the researchers thinks the proportion is greater than 1.8%. So now we can get our test statistic. We've got 18 out of 885. Hypothesis is 0.018 and right tail test more than. So test statistic to 2 decimals is 5.2. P-value to 3 decimals is 0.3. All right, so let's compare. So p-value is large, so p-value is greater than alpha. All right, so either A or C. Now, when p-value is greater than alpha, do not reject. There is not sufficient evidence to conclude that more than, which is the researcher's hypothesis. Certain drug can be used to reduce the acid produced by the body and heal damage to the esophagus due to acid reflux. The manufacturer of the drug claims that more than, here's the claim, more than 93% of patients taking the drug are healed within 8 weeks. So, portion equal to 93%. That's the standard. And then he comes along and he thinks that, claims that more than 93%. So we'll get 225 out of 240. %. More than 93%. Z0 to 2 decimals is 4.6. P-value, 3 decimal places, is 3.24. Large p-value this time, again, do not reject the null. There is not sufficient evidence. There is insufficient evidence. That's what you always want to say. According to a certain government agency for a large country, the proportion of fatal traffic accidents in the country in which the driver had a positive blood alcohol concentration is 39%. Suppose a random sample of 110 fatalities in a certain region results in 55 that involved a positive BAC. Does the sample evidence suggest that the region has a higher proportion of traffic fatalities? So again, this is going to be right tail test. So null is always equal to 39%. And then proportion is greater than 39%. And not quite sure what happened, but I don't know if it stopped recording or what. But it seems like I'm recording now, so we'll continue on with question 7. So again, we've got x by n, 55 over 110, 39 greater than 39. Compute, so we get test statistic is 2.37. And the p-value for this question, 3 decimals, is 0.009. And that's quite small. So since p-value is less than alpha, we reject the null and we conclude the researcher's hypothesis. All right, so again, previous poll, 37% of adults with children under the age of 18 reported their family ate dinner together 7 nights a week. Suppose that in a more recent poll, 388 of 1103 adults with children under the age of 18 reported they ate dinner together 7 nights a week. Is there sufficient evidence that the proportion of families who eat dinner together 7 nights a week has decreased? So this is going to be proportion back when is 37, and now the proportion is less than 37. Now we'll get the test statistic, which is 388, 1103. $37, less than 37. Left tail test, so minus 1.25. And p-value is 0.105, which is larger than alpha. So no, there is not sufficient evidence because the p-value is greater than the level of significance. Therefore, do not reject. All right, so this time 49% of parents of children in high school felt it was a serious problem. Their kids were not being taught enough math and science. Recent survey found 286 of 850 felt it was a serious problem. Do parents feel differently today than they did 20 years ago? So if it says differently or different than or something other than or not equal to, it's going to be two-tailed test. So proportion is equal to 49 and proportion is not equal to 49%. So we got 286 of 850. 49 not equal. 49 as statistic minus 8.95. P-value is small to 3 decimals would be, well, less than, it'd be 0 to 3 decimals. And so this time p-value is less than alpha. We reject the null and conclude there is sufficient evidence to say that parents feel differently today than they did back when. Okay. So 41% of respondents stated they talk to their pets on the telephone. Veterinarian believed this result to be too high. So if he thinks that it's too high, then that's saying that he believes it's less than. So proportion who talk to their pets back when, 41%. Veterinarian believes this is too high, so he thinks it's less than. And now we'll compare our sample evidence. So out of 277 said that they talk to their pets. 41. It's less than minus 0.72. P-value is 236. And so, no, the veterinarian's claim is not valid. So he does not have a right to be skeptical. There is not enough evidence to support, to conclude the true proportion of pet owners who talk to their pets is less than 41%. All right, so that is 10.2. I'll see you at 10.3.